Hi everyone, good morning. Hope you can hear me.
Yes.
Thank you. So thank you everyone for joining in today morning. I am Krishna Prabhu from NASSCOM COE Data Science and Artificial Intelligence, and I am joined by my colleague Supriya, who has taken a lot of pain in putting together this initiative. And we are also joined by one of the best teams in Intel, which has been led by Kavita, and also the technology leaders like Lakshmi and Subrata and Vinuta. Before we get into the detailed introduction of each of the members who will be presenting following me, let me give a brief introduction to the AI Pathshala itself. So this is the 17th workshop which we are running in NASSCOM COE under the AI Pathshala Technical Mentoring Initiative. And we, of course, focus, many of you would have attended it earlier. We specifically focus on data science and artificial intelligence. And more specifically, we are interested in the high performance computing space, because that is the cutting edge today with things like computer vision and natural language processing and so on at the forefront. And of course, we also cover other niche areas in the interest of the developer community as well as the research community to bring the best in research as well as development to the people who are working on the field. We have covered several other niche areas like robotics, NLP, edge computing, AI on the edge, and so on in the past. And of course, we have come a long way if you look at the history, like gone are the days when we had to program, say, massive matrix multiplication sort of things in Fortran or C++. And the next wave, we saw that there is additional layer of abstraction, which made the job of data scientists or AI engineers like us easier by introducing things like PyTorch or Keras and so on. And this is the third wave. It looks like Intel is leading the pack here, where we wanted to bring in a certain level of abstraction as far as the background architectures are considered. Either it is a specific OEM based operating system, or it can be CPUs or GPUs, FGPAs, etc. So Intel team has done a lot of work in this one. So let us hear from them. Without spending much time further, let me introduce you to Kavita, who will take over from here. Kavita, it's yours.
Thanks, Kashyap. Hi, everyone. A very warm welcome to the AI Pathshala and Intel Software oneAPI workshop. I'm Kavita Arur, and I drive the developer ecosystem for Asia Pacific and Japan. Today's workshop, you're going to hear more about oneAPI, which is a cross-industry, open standard, unified programming model, which develops a common developer experience across multiple architecture for faster application and performance and more productivity and more innovation to the developer community here. Before we begin the day, I would like to thank NASSCOM KTech Center of Excellence for Data Science and Artificial Intelligence for giving us this opportunity to come and present DPC++ workshop to the developer community here. We have some ground rules for the session today. So I would like to talk a little bit about that and take you through the workshop details and introduce the trainers for the workshop today. So the very first ground rule for the day is the Dev Cloud access. We have been promoting the Dev Cloud registration through the invite copy to all of you. I hope you have the registration process with you. If not, need not worry. We have the PDF and the URL, which will be posted on the Q&A and the chat window here today. So go through the Dev Cloud access guidebook, which has been submitted in some time now on the Q&A window or the chat window. All you need to do is input the event code there, and you should follow the steps given in the Dev Cloud Access Guide, and get registered to Dev Cloud. So this is mandatory. If you're participating in the hands-on workshop today, the Dev Cloud Access is mandatory. As you all are working from home, and we are today presenting from home, so bear with us if there's any internet connectivity or any tech glitch on the Zoom meeting today. So be connected, and we will come back on the internet very soon to present the workshop to you. Today's workshop will have the Q&A on the Q&A window, which is moderated by Intel panelists. So feel free to post in any of your questions with regards to the workshop or about Intel software on the Q&A window. And our panelists who are the moderators for the day, which is Lakshmi Narasimhan and Superna and Vinutha would be the key instructors and moderators for you on the chat window. We have some exciting poll questions for you to do, so don't miss them. We will be going through the poll questions as we go through the workshop. And there's a very exciting DPC++ contest to you, so participate, and it's going to be fun across the workshop today. Just to take you through the DPC++ contest, we begin the workshop contest now at 9:45 a.m. And then we close the workshop at 1:30 p.m. sharp as we close the hands-on exercise. So all you need to do is be attentive, listen to what the trainers are teaching you, participate in the exercises and the modules taught by our trainers. You need to submit the code in DPC++ only in form of screenshots and send out those submissions or entries to kavita.arur@intel.com before 1:30 p.m. IST. And we are going to announce the top 3 winners by 19th of October, which is this month. You have some exciting prizes to be won. So the top 3 winners will get the Neural Compute Stick 2. And we will communicate to you through emails who are the winners, and you will be shipped the NCS2 sticks. So go ahead and program and code using these toolkits and offerings from Intel. With this, I would like to introduce our key speakers for today. Lakshmi Narasimhan is our first speaker for the day. He's going to do an introductory session to oneAPI. Lakshmi Narasimhan leads the consulting team for developer product support and consulting division within the Intel Software Group. In his role, he's responsible for working with the developer ecosystem to help get the best performance from Intel hardware across AI, client, IoT, or HPC segments. He has been working with Intel for nearly about 16 years now, and has led several organizations across all these segments which I just mentioned. And he's a bachelor's degree in computer science and has completed his senior executive leadership program from INSEAD. He loves to read, write, and teach in his spare time. So Lakshmi is available today on the Q&A window. So network with him, talk to him, chat with him across anything you want to know about Intel tools and software. Our key presenter for the day is Superna Rekha Ghoshal. She is going to be our expert for the hands-on session on DPC++. Superna is a technical consulting engineer at Intel. Her expertise is in providing technical consulting services to Intel high-touch customers, and she helps them to leverage Intel compilers to get the best performance out of it. Before joining Intel, Superna was a video analytics algorithm designer for IP cameras and has got a master's degree in computer science from VIT. Traveling, photography, and interacting with people keeps her occupied for the rest of the time. Anything you want to know about oneAPI, DPC++, so she's the expert, go ahead and chat with her post her session across the Q&A window. Our last presenter for the day is Vinutha. Vinutha SV is a technical consulting engineer at Intel, and she focuses on performance characterization optimizing using Intel software tools. Prior to this role, she has an application engineer, and she has a bachelor's degree in computer science and master's degree in software engineering. So she's our expert today for VTune Profiler beta. So look forward and interact with her poster session on the Q&A window. So with all of this, I would say, all the very best. This workshop is going to be exciting for you. So hold on there for nearly about 3.5 to 4 hours today. Your Q&A window is open, so feel free to chat with our experts there. And the session today has been recorded, so you will get a copy of this post workshop as well. Good luck, and I hand over the session to Lakshmi. Lakshmi, over to you.
Thank you, Kavita. Can you all hear me okay? Can you see me okay?
Yeah, good, Lakshmi.
Awesome. Okay. Okay, so let me before I start with the actual agenda, what we will do is we'll do a quick poll now, Kavita. If we can have the first poll on the screen, that would be great. It would just give us an idea of what kind of developers we have in the call today. So I would appreciate if we can have the first poll live. Thank you. So you should have, the attendees should have had the poll on your screen now. In case you are using a browser to join instead of the Zoom app, you may have to disable the pop-up for this poll to appear on your screen, just FYI. In case you didn't receive the poll, you could just raise your hand so that we can. I can also just call out the question if, in case you didn't receive the poll, you could just type on the chat window as well. So, which domain do you come from? Is it HPC, AI, GPU, FPGA programming, or others? Anything else? Okay, so we have the poll results. We have a fair mix, a lot of the folks from AI and a mix of HPC and GPU, and also some amount of course, a lot of people on the FPGA side. We have an equal mix of the rest. Pretty much 50 plus people are from the AI background. So maybe when I focus on my presentation, I will surely cover a little bit more on what is there for you as an AI developer. And in the interest of others, we will also talk about HPC and GPU. And this is primarily targeted for HPC and GPU users as well. So we have we have a lot of content for each of those who are available in the session. So stay tuned. So thank you for answering the poll. With this, this is the rough agenda we have for the day. So we will start with an introduction to Intel oneAPI. I know many of you are still new to oneAPI. And then because the workshop is going to be on the Intel Dev Cloud, we will make sure that all of you are set up with the Dev Cloud so that the workshop you can do hands-on on the Dev Cloud. Then we will have a fundamental session on data parallel C++, followed by a lab. And after that, we will also have a little bit deep, we'll go deep dive into data parallel C++. Post that, we will have Vinita, who will talk about the profiling of applications, data parallel C++ applications using vTune and Intel Advisor. So these are two performance profiling tools which Vinita would be talking about. So this is the rough agenda we have for the next close to 4 hours. So stay tuned. Okay, all right. So let me start with the programming challenges of today. I know today all of us are attending the call using Zoom, and of course there are multiple other things that may happen in the backend to really help us having this successful workshop, right? So this is one kind of workload that we are talking about. In parallel, you may be creating AI models, you may be inferencing using the models that have been created, or you could be doing any n number of other things at work when it comes to the different workloads that you deal with. You may be having a database workload, you may be having an AI model, you may be having a packet processing workload if you're talking about the network traffic with respect to 4G, 5G, and all of that. So there are all these different types of workloads. In the past, it's not that we did not have these in the past, but the volume of these have increased tremendously in the last if you look at the 2015 to 2020, the last 4 or 5 years, it has increased tremendously. And the challenge is that it's not that one hardware can do all of this really well, right? So there are specific hardware which does specific things really well. If you look at CPU, it's intended for any scalar kind of activities, and also with a little bit of vector where we have the vector registers like AVX and all that. So it can also do a little bit of vector processing, but GPU is really the master when it comes to vector processing. When it comes to FPGAs and when it comes to the matrix processing, right? There are all of AI workloads is pretty much like matrix processing. So what happens is that even though CPUs and GPUs can really do it, but now we are really looking at specialized hardware that can really do this for us, so that we can really spend less time in terms of, let's say, whether it is training or inference or any other aspects. Like for example, if training is taking a day to complete, maybe if you're using a specialized hardware, it could take as less as like half a day, right? So that is huge amount of productivity boost for the developers. And of course, when it comes to FPGAs, these are programmable. If you look at FPGAs, how they are designed, it is a programmable hardware where you can program the hardware to suit your workload. So that is where, if let's say it is really a very, very low latency application like packet processing and those kind of things, you can really program the hardware to suit the type of software workload that you have. So now the workloads have really diversified. Now the hardware has really diversified. But the challenge for the programmers is the programmers have to really address all these different hardware. So how do you address this hardware is the biggest challenge. And of course, each of these hardware have a complete set of tool chains. For example, if you take FPGAs, they have their own RTL code, and it's very hard to get an RTL developer to really program to the FPGAs. FPGA programming is one of the most complicated and difficult aspect when it comes to the program. So now each of these platforms also come with its own software challenges and software investments that we have to make. So if you look at an average developer, I think all these challenges exist today, and it is only going to grow as we speak. So now this is where I want to introduce oneAPI to all of you. So what is oneAPI? So it is a programming model to simplify development of across diverse architectures. So we spoke about all these different hardware that is there, and we have FPGA, we have CPU, GPU, FPGA, and other accelerators. When it comes to programming these, we saw the different challenges in the last foil. So how do we address this? This is through oneAPI. So what we are trying to do is, whenever I think when KP was talking about the abstractions, a lot of the abstractions we have, the primary concern for the developers is that, hey, will I lose out on the performance because I'm using an abstracted language? For example, let's say .NET, Java, or even Python, or any other language that you use today. Most of these are really abstracted languages, and even including the frameworks like TensorFlow and Keras and all those that KP talked about. The challenge is that, would you really get to native performance when you're using these frameworks? That's the big challenge that we have. So the idea of oneAPI is to, because it is a level of abstraction, but how do we really get the native performance of, let's say, a C++? So that is the objective with which we introduced oneAPI. So now the other challenge is that when we spoke to a lot of our customers, the first and foremost challenge they spoke about was, hey, no, there is only one solution today. We want multiple choices. We want alternatives. So that is where we thought, when we build something, it should be something that is industry standard, and it should be an open specification. For all for all those who are in this call, if you are not familiar, we have also released the oneAPI spec that is available today in oneapi.org, and the version 1.0, the final version, or the final draft before the gold launch, is actually available today, and you can download it from oneapi.org. And the other bigger challenge, thing we have to consider when we are introducing this kind of a new concept and new initiative is that it has to be really interoperable with the existing programming models. If you look at HPC, today HPC, a lot of HPC is still on Fortran. So how do we make sure that it interoperates with the existing HPC applications, with the existing programming languages? So that is what we had to think about when we introduced oneAPI. And in simple terms, oneAPI is going to address this challenge of having to talk to these different hardware and making sure that it is based on standards, and it also is going to be interoperable with the existing programming models. So this is oneAPI in a nutshell. And okay, so what is the backbone for oneAPI? So this file essentially talks about what do we have inside oneAPI. So one of the biggest thing that we have in oneAPI today is the data parallel C++ programming language. So this is what this workshop is all about. And Superna is here, who is going to talk about data parallel C++ to you for almost like close to 2 hours, along with hands-on sessions. So I let her do majority of the work when it comes to data parallel C++. But all that I wanted to mention is that this is a new programming language that basically extends existing C++. And for those who are familiar with SYCL, which is again a standard defined by Cronus Group for heterogeneous programming. So data parallel C++ is an extension to SQL and C++, which helps you program to the multiple hardware that we are talking about. And apart from this, so this is for direct programming. When it comes to, let's say, I don't want to really use DPC++, but I have my own languages that I am writing the code on. I want to just make sure it is interoperable. So that is where the API-based programming makes much more sense for you, where you can see that the libraries, there are a bunch of libraries that are available that you can utilize. Let's say you're using a standard library. Instead, you replace that with an Intel optimized library, which can scale across multiple devices. The advantage with these libraries is that it can run across these multiple hardware we are talking about. So two choices you have. One is use data parallel C++ if you want to directly code and program to the hardwares with at the level of abstraction we need. Or you can also choose an API-based programming through the libraries that we have. So now let's just talk about what libraries do we have. So when it comes to libraries, of course, math, threading, DPC++ library, analytics, ML, deep neural network, MLCOM is nothing but if you have a multi-node training that happens, how does all these nodes really communicate to each other, and video processing. So these are different libraries that are available within our oneAPI toolkits. And of course, math is something that's fundamental to any workload, and especially for AI, this is really the backbone, right? And of course, threading is to make sure that we have something called threading building blocks, which helps you parallelize your code across the different cores and across the different machines that you have. And DPC++ library, it is nothing but some of the DPC++, the programming language that we talk about, it also comes with its own set of libraries like STLs, which we will use. And this is, if you don't want to really code using DPC++, you can alternatively use the DPC++ libraries as well. For analytics and machine learning, we have a bunch of softwares and libraries, including Intel's own distribution of Python and data analytics library, and Intel's own versions of TensorFlow and PyTorch, where we have optimized it. So let's say you know for sure you're going to run this training on Intel hardware, or going to run this inference on Intel hardware. All that you do is, instead of using a regular TensorFlow, you just download the Intel's TensorFlow version and then you run it, which is going to be automatically faster because it will internally use some of the libraries like DNN, which is the deep neural network library, which is part of the oneAPI toolkit. So the idea is that for you, if you're running your workloads on Intel architecture, we want to make sure that you are able to leverage all these underlying libraries and get the best performance out of it. So that is the whole idea of the API-based programming. Now, okay, so this is all great. How is it available to an end user? So if you go, okay, to tell me what do I have to do today? So oneAPI is available today to all of you, and all that you have to do is go to software.intel.com/oneAPI, and this is the set of toolkits that are available for you to download. So you can download this from Intel's software.intel.com portal, and this is how it would be presented to you. So let's go over one by one so that you understand what is there in each of these toolkits. So the first one is called the base toolkit, where it has got all the bare metal, when it comes to heterogeneous programming, all the compilers, all the libraries that we spoke about, they are all part of, and also the performance profilers that we will talk about in the second half of the session. All of these are present as part of the base toolkit. So in summary, whatever is required for you to do heterogeneous programming across domains, that's the most important thing, across domain would be available as part of the base toolkit. And apart from the base toolkit, we also have domain specific toolkits. If you're a HPC user, if you're an IoT user, if you're an AI user, so we have domain specific toolkits that we have created, which will either leverage some of the components of the base toolkit, or it could be pretty much on its own. But for most part, they would be utilizing the components of the base toolkit to accelerate the performance. Just to take an example of HPC toolkit, the Fortran compiler is not part of the base toolkit, so that will be part of the HPC toolkit because HPC users really need a Fortran compiler. So, and apart from that, you also have tools like Intel's trace analyzer and collector, also the MPI library, which is used for scaling your application from one node to multiple nodes. So this is part of the HPC toolkit. And then IoT toolkit. So whatever is needed for you to really work on an IoT specific use case. So all those tools are bundled as part of the IoT toolkit. And again, it will have some of these performance profilers, and then the power, because IoT, there's a lot of focus on power. So we also have some specific tools to optimize for power and so on. And the Intel oneAPI DL framework toolkit. This is something that is going to be very crucial for framework developers. So when I mean framework developers, who are the framework developers? If Google is developing TensorFlow, or let's say Facebook developing PyTorch, these framework developers essentially use these toolkits and then write TensorFlow and PyTorch when they have to really target Intel architecture. So that is where, to ease the developers when it comes to the productivity. So what we have also done is we have our own TensorFlow versions and PyTorch versions which you can download. And apart from this, we also have the render toolkit, which is if you are in the animation space, movie making space, there are you know how costly rendering is in terms of compute. So we have specific toolkits and APIs and libraries that are focused on rendering. So this rendering toolkit can be used for accelerating the render workloads. And AI analytics toolkit, this is where most of the AI related, as a user, I think I just want to differentiate here between the DL framework toolkit and the AI analytics toolkit here. So the DL framework toolkit is for framework developers. But if you are a normal AI developer, all that you have to really know is AI analytics toolkit, which has got all the optimized frameworks, and then the Intel distribution of Python. So all of these things, right? So for all AI developers out here, if you want to just do one thing after this session, all that you have to do is just go download the AI analytics toolkit, which has also got the Intel's optimized version of Intel's distribution of Python, where you have these different packages like NumPy, SciPy, which are accelerated on Intel. Because one thing that AI developers, most of the AI developers predominantly uses Python, but again, Python is an abstraction, and when it comes to Python and performance, they don't really go well. So that is where what we have done is, we have underneath Python, we still use the native libraries, make sure we get the best performance even when you're using Python. So these are some things that we have done with all these different toolkits. And of course, the Intel distribution of OpenVINO. This is another toolkit that is again powered by the base toolkit, where it uses the deep neural network library. And this is primarily for inference. If you have let's say a model, all that you want to do is just do inference. You pass the model to OpenVINO, it gives you an intermediate representation, and then you use this representation to do the inference on the specific hardware, target hardware, and all the optimizations are taken care by the OpenVINO toolkit. So this is again powered by, we call it the powered by oneAPI.
I think we are lost Lakshmi. Let's wait for a few minutes. Let him send in again.
Hi everyone, sorry for the tech glitch here. Lakshmi must have lost his connection. He's going to join back. Give him a couple of minutes, please. Okay, Lakshmi, I think you lost the connection, so you're back.
You're back.
Okay, I don't know when you lost me. Can you just tell me when you lost me?
The deck, the slide where you're talking about the kits.
Okay, so so is it
You're
from the
talking about
beginning?
a level of abstraction
Okay.
Yeah.
overcome by C++, leveraging the Python libraries and so on. Yeah.
Okay, so did you hear about the OpenVINO toolkit? Kavita, did you hear when I was talking about OpenVINO toolkit?
Yes,
Yeah,
I
yeah.
did.
Yes, Lakshmi.
Okay, awesome. Okay, I think then pretty much I was done with this file. So just to summarize, the whole concept of oneAPI is to address the heterogeneous compute needs of today's workloads. And if you are a developer who wants to really target multiple hardware devices that are available today, oneAPI is your answer. And all that you have to do is, of course, even if you don't have all the hardware that is needed, we always have the infrastructure that's called DevCloud. If you want to try out oneAPI, all that you do is you just get an access to DevCloud, Intel's DevCloud, and by attending this workshop, you are entitled for the DevCloud access, and you will have it for pretty much like 120 days, which can be extended on need basis. So all that you do is you just log into oneAPI or the DevCloud, and the toolkits are already available for you. You can just right away start experimenting those. Or alternatively, you can download these toolkits, different toolkits, and make sure you can try it out on your own machines and servers. That is also a possibility to ease the developer productivity. What we have done is it is available on DevCloud. If it is feasible for you, you could just try out everything. So call out is, of course, use DevCloud and make sure you are able to test your workloads on the DevCloud. Now, with that, I'm done with the introduction to oneAPI. So now what we will quickly do is can we have the next poll, Kavita?
Lakshmi, the poll is live. I hope you can see it.
Yeah, we can see it. Yes, thank you. Okay, I see 78% of the people are having. Am I still sharing my screen? Are you able to see my screen?
No, Lakshmi, I think you've stopped sharing your screen.
Okay, let me just reshare it so that. Okay, at least I'm glad that at least majority of the people have access to DevCloud. In the interest of people who don't have access to DevCloud, please make sure if you are registering for DevCloud, this is the code for DevCloud access. Please make note of it. It's oneAPI VIRT virtual 08 OCT, right? Just I repeat, one is number one API VIRT 08 OCT, right? So this is the code for today's workshop. And what I will do is just quickly walk you through the process. If you don't have already access to DevCloud, the next 10 minutes you can get started. It's not a, it should be really fast. So let's just walk you through the process. So just go to this particular URL. So Kavita, if you could just paste this URL on the chat window for folks to really log in, that would be great. So for those who have already registered, this step is not needed. I will tell you when you have to start following my instructions. Until then, you can just, this is only for people who have not yet registered, just to be just to reiterate. So all that you have to do is just fill in these details, and then of course there are also other things that you have to do. Fill up in terms of what kind of developer, and also the code that you have that we just flashed, oneAPI VIRT08OCT, and then you submit a request. So folks who have not yet registered, if you can just tell us that if you're able to access it and you're able to register, that would be great. And then you would get here, it would just ask you to accept the terms and conditions, and then you click on submit. Once you do this, you would have received an email like this. And for those who have already registered, you would also have received this email. So if you can just pull this email up and get ready with the URL, that would be great. So I will pause here for a few minutes so that people can get to this stage. Until you have the email, please make sure you give the email that you have access now, so that because it's going to immediately send you an email. So Kavita, can we just quickly check if people are okay, are able to get till here? You can just
Yes, just a second.
Yeah, you can just let me know once people are ready and I can move on.
I think if people are not following this, please type in the chat window, and we can wait for you for a few more minutes to get you to the step. Can you please text us on the chat or the Q&A window? Thanks.
Yes, okay. One yes, Q&A window.
Let's give them a minute or so, Lakshmi.
Sure, Kavita.
Can everyone use the raise your hand feature next to your name on the participant list for us to know if you are all set up with the email? We have 2 hands raised so far, Lakshmi.
Okay, so should we go ahead then?
Maybe just a minute.
Yeah,
Let's
let's give a minute. Yeah, let's give a minute. Okay, Kavita, so should we move on?
yeah, let's proceed, Lakshmi.
Okay, awesome. Okay, so now once you have this email, all that you do is just click on this link that you have, devcloud.intel.com/oneAPI, and you just click the link. And it's preferred to use
You are not audible, Ellen.
Ellen, maybe you can switch off your video because your voice is cracking.
Superna, do you want to take over from here?
Sure, Kavita, I can do that. I don't think so many people have raised hands. So one quick check again. Have you all got this email?
We had about three hand raised, yeah. Two right now.
So Kavita, should I share my screen and start with the rest of the steps, or should we give a minute for Ellen to join back?
I think he's back.
Yeah, he's back. Maybe Ellen, you can put your video off and just try with audio, because sharing screen and video together is causing this issue, I think.
Sure, not a bad idea. Okay, all right. So once you are here, click on the connect button on the top to the right.
Ellen, you need to share the screen. We are not.
Sorry. Okay. Thanks for the reminder. Okay, so once you're here, you click the right, on the right hand side of the screen on right top, you see this connect button. You just click the connect button and you should be in this page. You will get this page where connect with the terminal or one-click login. So all that you do after this is just click on the one-click login and you should be set. You should have the window like the one that you are seeing here. And after that, just click on the terminal. And you should have a terminal on your screen. So after that, all that we have to do is we have to copy the exercises onto your local home directory. So Superna, can you just confirm if this is the same directory or it is a different directory?
I will paste the directory here for all the panelists here.
Awesome. Okay, cool. So just make sure when you are copying the data, just use the command that Superna is going to post on the chat window. And then on the terminal, you just type that window type that command, and you will have all the files copied onto your home directory. And once the data is copied, you should have something like this, where you click on the introduction to Jupyter Notebook, you will get this code to the right-hand side of the screen. So let's make sure all of you are able to get to this point so that you can be successful with your workshop and the lab that you would be doing for the next, let's say, an hour or two.
Yeah, I have pasted the link. So instead of maybe, Ellen, can you display that screen once again?
Sure.
So instead of this, like this highlighted line of data oneAPI workshop Jupyter notebook.sh, instead of running the script, just copy the file from the path that I have mentioned in the chat to your home directory, and then just untar the file, and then we will be good to go.
Awesome. Okay, this would essentially end your DevCloud setup. If you're able to log in successfully, you are set. And copy the files to your home directory, you should be good to go.
So folks, all of you, let us know which is a step you are stuck in so that we can help you now. After we proceed from here, it will be very difficult for us to attend if anyone is not having connection to DevCloud or stuffs like that. So let us know where you are so that we can help you now to get proper access and make your DevCloud setup ready before we jump into other slides.
Okay, so if all of you are here, then you should be good to go. If we can just have a quick show of hands as to how many people were successful with the DevCloud setup, that would be great. So all that you do is just give you a thumbs up on the with the emojis, and we will be good to go. So Kavita, is that okay? Do we have anyone is stuck with any setup issues or something?
We haven't heard. I think there is only two hands are raised. So maybe a minute or two. Yeah.
Kernel for you
Some
to
people are
choose.
stuck on the kernel. They're not able to choose the kernel, or Jupyter Notebook is loading slow.
Yeah, sometimes it will just ask you to start a server. Just click on yes, and you should be good. So is this the so Superna, this is the IDP kernel that they are talking about, or the IDP version? Is it the Python version that is being asked? I don't know. There was a user who was asking about the kernel version.
Yes, Ellen, it's the Python kernel.
Yeah. Okay, one click is loading slow. It is okay. First time it would be slow because it would it would try to start the server, etc. So it would take a few minutes. It's okay. As long as you're able to get there, that should be fine. Okay, with that, I can stop sharing and I will hand it over to Superna for taking charge of the DPC++ part of the workshop. Thank you so much. So Superna, I'm stopping my sharing. You can start sharing.
Can you see my screen?
Yes, Superna.
Yes.
Okay, I think there are still some question answers. If anyone else wants to take those questions up before I start, that will be helpful. Vinita, maybe you can help them. They are reporting an error.
Yes, Subarna, I'll take it.
Okay. So should I go ahead or wait for a few minutes? Kavita?
Couple of them have still the error and they're not able to get into the folder, Subarna. So maybe we'll give them a minute or two to settle there. Thanks. Okay. Guys, everyone, if you are connected, if you are on the folder and all set to go, please raise your hand so that we know and we can kickstart the hands-on session. Thank you. When I see about 5 hands raised, Ellen, do we have any more questions to answer, or we are good to go?
No more questions, looks like, Kavita. We are good to go.
I think, Superna, I think, sorry, Kavita, there was someone who was saying that they still, Bhavtosh Bharadwaj was saying he doesn't have the interface. So Bhavtosh, just wanted to check if you have the interface up and running now.
You want me to check, Ellen?
No, I'm just asking Bhavtosh.
Okay.
Yes, it's running. Okay, I think he's up. Okay, I think let's then move on. Yeah.
Okay. So welcome everyone, a beautiful morning to all of you. Myself, Superna, a technical consulting engineer. I will be walking you through data parallel C++. So let's first I'll just let you know what are the expectations of the session. So this session will help you understand DPC++ programming language and the simplicity of running it on accelerated devices. With that, let's move on to the agenda. Okay. So I'll start with introducing you to the programming language, followed by a line-by-line code walkthrough through a basic DPC++ program. And then I will give you time to implement that program on Jupyter Notebook. I'll let you know how you can implement it on Jupyter Notebook, and I'll give you some time for all of you to implement that. After we are done with the lab, we will have a short break, and then we will move on to the deep dive session of DPC++. So there we will be discussing about what all platforms are required for DPC++ to run, the execution process of what is happening inside when we are executing the commands, and the memory model, as well as the kernel execution model. So with that, let's start with the introduction. Data parallel C++ is a familiar programming language because it uses C++ language constructs like lambda function and templates. And in addition to that, it incorporates SQL spec for enabling heterogeneity. So above C++, we have SQL spec, which enables the heterogeneous programming language. And Intel has established a DPC++ project to drive broader adoption. So we implement our own features, and that gets most of the features get incorporated in the SQL Next that is coming up. So all of this constitute a DPC++. So all of you may be wondering why we have chosen SQL for the heterogeneous programming language. Basically, SQL is one heterogeneous platform where we can write a single source of code, and that code can make the program run both on the host and device together. So that's the ease of use for the users. And one more thing is we have started with SQL, and we have less, like initially when we started off with SQL, the verbosity was much more. If you see the programming language now, and if you are familiar with any other heterogeneous programming language, you will easily find how easy it is to write a DPC++ compared to other heterogeneous programming language. So these are the key points of data parallel C++, that it's a very high level language that I already discussed, and this is designed to target heterogeneous architecture. And we can reuse the same code across CPU and any other accelerator. That's the beauty of a single source programming language. And moreover, it's open source, and I will provide you the GitHub link to it. And anyone can contribute to the programming language and make it better for all of us to use. Okay, before I start going through line by line through the DPC++ program, let me give you an idea of some basic terms that we will be using inside the programming language. So these are C++ concepts itself, but still I wanted to reiterate because we will be using this to write a kernel function. This is basically a lambda expression. So those of you who may not be aware of what a lambda expression is, let me quickly go through it. So here in this short code snippet, you can see that we have a sort function, and inside the sort function, we have a function that is defined here only. So basically, here what is lambda function? Basically, it is defined in the place where it's called. So you don't have to define it separately. So these are anonymous functions. You don't have any names to these functions. And the lambda function basically has two parts. One is the capture clause. I'll explain what the capture clause is. And then you will have the parameter list, the parameters which will be used in the function. So what the capture clause is, if you want to pass anything, any variable from out that is not inside, like inside this function, you want to pass the value inside the function, you can define those in the capture clause. So if you had A and B defined before and you wanted the same values to be passed inside, you could have defined it in this capture clause. So what it does is it basically has, like, either you can pass the values, or you can do a pass by reference. So either you can pass the value or the address of any variable you think will be needed inside the function. You can pass those here. So this is a capture clause, and then you have the parameter list. So this is a short of how a lambda expression is written. We will be extensively using this when we write a kernel in DPC++, and I thought it necessary to mention it before I start the program. So next, let us see how a DPC++ programming flow goes. So we have a host from where we want to launch a kernel. So basically, when do we use DPC++? When we have like complex computations and we want to execute it fast. We want to use some accelerated device to accelerate the speed in which the execution goes. So we want to upload a portion of our code to the devices. So the place from where it's offloaded to the device, that is a host. It basically launches a program and then uploads a part of the program to a device. And then if we see inside the host, we will have buffers. Buffers are, like, don't get confused with the names. These are all C++ terminologies only. Buffer is basically a data type which helps the device to access the data that is stored in arrays. So what we do is when we get like the value in the array, we just save it in buffer so that it's easy for the device to access it. And then we have the accessor. Accessor basically provides the permissions of how we want to access the buffers. And then we have a command book handler that usually shapes the buffer and access it together in such a way that it can be accessed in a device. And then you can think of it as a capsule kind of thing, and then we pass it over to the device with the help of a queue. So queue helps us execute the commands on the kernel commands on the device. So with that, let's move on to a basic DPC++ program. It's called a Hello World program, but it's actually a vector add program. So this is the first step of a DPC++ program. So what you do in the first step is you just include the headers. We can include this is the header that we always want to include as a first step of this. And after that, we want to include a namespace, a physical namespace. So here, if you want to include any other includes or namespace, this is the first step of the programming language. I think this is the first step of any programming language. But what you should keep in mind here is your include should start with this include, and then you can go ahead and include anything else that's required. So basically, it includes SQL headers and provides a template and definitions to interact with the DPC++ runtime library. So that's why it's used for. So let's move on to the next step. Next step is creation of buffers. So as you see, we use a buffer keyword and then we give a name to the buffer. Here, this is a vector add program where we have taken three arrays A, B, and C. So we are passing the values of A, B, and C in the buffer. So buff A will have the entire content of A, buff B will have the entire content of B, and so on. And then the second parameter is the range parameter. So what the range parameter is used for is array A is having a particular size. So if you want to pass the entire size to the buffer, you give the entire size. Or if you want to pass half the size, you can give size by 2 and so on. So it's basically defines the range through which the buffer will be copied from the array, like the array will be copied to the buffer. So if I just want to mention a few steps about the buffer, so it reserves the memory actually on the device and host and initializes initialize the memory with the host values. So the host values are A, B, and C; those are getting initialized on the buffer. So moving on, in the third step, we need to create a command queue, as I mentioned. So here you can see I have created a queue here, and actually queues are specific to a particular device. So if you have 4 devices, so you need to create a queue for each device. A queue cannot be common for more than a device. So we always create the command queue for a specific selector using the device selector. So here you can see we have created a GPU select. We have created an object of GPU selector, and we have passed this device selector in this queue object. So what we have done is this is a device selector. This is a GPU selector. So we wanted to create a queue for the GPU. So we have created an object of GPU selector, and we have passed that in our queue. So as you see the syntax of queue, you need to mention the queue keyword followed by the queue name, and then you can mention which selector you want. There is another syntax. If you don't want to mention this object separately, you can directly mention GPU selector here. Maybe I'll show you at some later point how to do that. So it will skip a step for you. So, and one more thing I wanted to mention here, you can mention the GPUs, you can have a GPU selector, a CPU selector, or an Intel FPGA selector as of now. And then even if you don't mention any selector here, it will by default choose a selector, but it's always a good practice to mention a selector, because you never know when the system chooses a queue, like a device for you, which device will be selected. So it's always safe to mention the device where you want to run your kernel. Moving on, the next step will be submitting through the queue, as I mentioned. So as you see the syntax, we first have the queue name, and it has a property called submit. So you mention submit here, and then as I mentioned, the kernel syntax, we are passing by reference here. What we are passing, we are creating a handler object, and we are passing that here, and this will help us submit of the kernel in the queue, this syntax. So submitting this to the device by calling the submit method and provide the method with a lambda object. So this is the lambda object we are providing. This is the step. And now we have the step where we want to create accessors which will access the buffer for us. So we have 3 buffers, A, B, and C. We create separate accesses for all the 3 buffers, and we can give access to the buffers like this. Since it's a vector and code, we want to read the values from A and B and copy it to C. So we gave read access to the first 2 buffers and a write access, a read-write access to the third buffer. So if you don't mention any access by default, it will be a read-write access. Otherwise, you need to mention which access you want to. It can be a read only, it can be a write only, it can be read-write, anything. And so as you see the syntax, after like the way you create the accessor is you need to call this get access method, and you need to pass the command group handler object that you created here. So you had created a command group handler object here. You need to pass that command group handler object and then the permission you want to give to this particular buffer. So that's how the accessors will be created. Going ahead, this is the step where we actually submit the kernel. So we have properties of our command group handler. This is parallel for. Parallel for ensures that the kernel will be executed in parallel. So whatever we are mentioning inside the braces after this portion will be executed in parallel if we write parallel for. And we can also write single task. In that case, the kernel will be executed serially. And we can also write parallel for work group. In that case, I'll go in more details later, but the parallel for work group basically lets you divide the small chunks of kernel into groups that you can separate there. So this is a little complex concept which we will come later on. Now you don't have to think about that. So just understand that parallel for will just execute this in parallel. We give a name of the kernel. Here it's the class vector add, but this is optional. But it's always a good practice to give the name. And then this is again the range. This is the range that the parallel for will walk through. So for all the case it's n, for all the buffers it's n. We are mentioning that here. And then this is the iterator. So it usually actually lets you iterate across these buffers. So we have mentioned it as I. So that's how we are doing it. So now we have the final code. We have all the bits and pieces that I showed together here. So this is the basic body of the code. First, you have created buffers. Then you have copied the content of your arrays to the buffer. Then you have created a queue. And so as I was mentioning here, if you don't mention any particular device selector, like in the code we had GPU selected, here we have just mentioned my queue. By default, it will select a device, but it's not a good practice. I just kept it to show you that this is also possible. But you should always, always a good practice to create a selector, a queue for a particular device. You should always mention that here. It's a good practice. And then we have started submitting on the kernel to the device. We have created accessors inside this and mentioned how we want to execute the kernel in the device, and then this is the final kernel. So as you see here, this is the host. This all of the host code. I'll come in details in the last portion where we are actually copying, like displaying the results, and this is the accelerator code. So this portion is this accelerator device code is the only portion of the code that gets executes in the device. This CI equals to AI plus PI is the only portion of the code that is actually getting executed in the device. Rest all are getting executed in the host. So one catch here is you can see that when we started the program, we had copied the contents of our arrays to the buffer. But after we have entered the program, you can see we have directly printed the CI and it will give you the correct results. But you must be wondering how is that possible, because we didn't copy the contents of CI back to our original array. This is possible because all the operations we are doing is inside the scope. So what is happening for that is when the scope is ending, the contents of all these arrays are getting copied back of the buffer, of all these buffers are getting copied back to the arrays itself when this scope is ending. If you are not putting the scope of operators, then you have to explicitly make a copy back of all the arrays, all the buffers into your arrays. Okay. Now I will show you what you need to do for your hands-on session. So please, all of you, go to your Jupyter notebook now. So you will have a folder named like, what's the name of the folder? October or workshop October 8. You will all have a folder named that. Please raise your hand if you are all in this folder. October 8 of workshop 8 October. Kavita, can you check whether all of them are inside this folder? I have asked them to raise hands.
I just see a couple of hand raised. Let's give them a minute.
Okay.
About 5 so far.
Oh.
6. About 50% say they're here.
So anyone has reported like why they are not able to come here? Those of them who have not raised their hands.
There's nothing mentioned in the chat window, so maybe we can request them to type in on the chat window or Q&A if they have any error or they're facing any issues to reach here. Are you all on the same page? We have about 4 or 5 hand raised here.
Okay,
So, yeah.
I think someone has mentioned something in chat box also.
They're all ready, I guess, yeah. Few of them haven't responded, but I think we can proceed.
Okay. So what you need to do here is after you are in this folder, click on the vector add folder. So inside the vector add, you will have this orange color flag first dive. So just double click there. So if you double click here, you will see that the code is just in similar pieces that I initially showed you. So you have the first block where you need to mention the headers. Next portion is the creation of the queue. You need to write your code here, how you need to create a queue. So if you have followed my workshop, maybe I will also display the queue part. You will be able to create a queue here. And then you need to create a buffer here. If you have followed my session, you will know that there is a small parameter needed here, and that will make it go. And then the third step is submitting to a queue, and the fourth step is displaying the result to verify that whether it showed correct result. So all you need to do here is just go to this block, and after you feel that the block is complete and you don't need to add anything more, you just need to do control plus enter here. So if you need to press the control and enter key together, you need to fill the code first, and then you need to press control enter so that the code executes. And after that, you can just this portion will merge all the code in a main.cpp, and then this portion of the code will build it for you. So just do this 4 portions. If you already execute this, then you will see in this panel you will have a main.cpp file. So just copy the contents of the main.cpp and the results that will get displayed here for the contest that we are having, and post it to Kavita's mail. Right, Kavita? They should post it to your mail, right?
Yeah, send it to me, send us a screenshot to me using the DPC++ code only. Kavita.arur@intel.com before 1:30 p.m. today.
Yeah,
Thanks.
please do that. And if you feel that the code is too big for a particular screenshot, you can they attach can they copy the code and paste it in a Word file or something, or only screenshot is allowed?
Yeah, they can make a doc out of it and send it to us.
Yeah, anything is fine. We want to see the entire code as well as the results. So from here, I will let you work on the hands-on exercise. Maybe we'll give you 15 minutes for that, and then we will move on to the deep dive session. Okay.
Vinita, I think Bob Tosh had said that he's only seeing the temp folder. Maybe if we want, we can just quickly have a private conversation with him to help him get to the exercises.
Okay.
Okay, I'll show you again how you should go to the October 8 folder. So initially, when you execute the copy command that I pasted in the chat box sometimes back, so I'll display it here again. All you need to do is execute this copy command, cp data oneAPI workshop, then copy October 8, workshop 8 October TGZ to your local folder. And thus you get this. Just under that with this command, I had pasted these two commands. I'll paste this again in the chat box. Please follow that and you can copy.
Hi guys, a quick request. If anyone of you wants to speak, the participants, if you want to talk and ask a question, please raise your hand and we can unmute you, and you can, network or coordinate with Superna on this session today. Thanks. Yes, Naveen, do you have a question for Superna?
I think he needs to.
Yes, Bhavtosh, you can go ahead.
Yeah, I tried to execute that same command, but it is not executing. It is saying something else. So I would like you to just explain us the interface first of all, that what is the thing where we have to click and for what, so that I can understand where in what file or in what terminal we can execute this. I'm not understanding what type of terminal is this.
Okay, let me explain again. Okay, so when you open your Jupyter notebook, it's like this, like nothing. You will not have any folder. I have some folders, so you will basically get a screen like this. Do you have that? You can just reply and go ahead and do the steps with me. Do you have this window?
Yes.
Just click on terminal.
Just a second. No, I lost that. Just a second.
Yeah, maybe you can the URL you have got in your mail. You can paste that copy and paste that URL again, or in Google, and then you can reopen it.
In email?
You should get a DevCloud email, right?
Yes, I have received an email where I got username, name and password, and I logged in that.
Okay.
After that, I
Maybe
see
the way you have logged in, just like re-log in and come back to this window.
I did same thing. So in that one, I see TMP folder and welcome file is there.
Yeah, but you have this screen, right?
This launcher. If that screen is not there, from where I
just add plus.
Sorry.
This
Okay.
Plus.
Okay. Yes, I got it.
You got it, right? Now go to others and then terminal.
Okay. I did it.
So here just paste the two commands that I gave. That CP command, first paste that.
Okay.
This is the command, right? Just double check whether
so it says that missing destination file operand.
I'm not sure. Can you?
I think it's possible that he missed the dot slash in the end. Are you sure you had a dot slash in the end?
In the end?
Yeah. After TGZ, just see the command. There is a dot slash in the end after TGZ. After TGZ, there is a space and dot slash.
The Zoom also hung.
Just wanted to check how others are doing as Superna tries to help him out.
Dot. Okay. Right.
Were you able to execute this command? You can see my screen. This is the entire.
I'll try it once more. Because if that dot slash is important, did not know.
Yeah, like you need to copy it.
That is the destination. Yeah.
Yeah.
Okay. Sorry. Yes, it worked now.
Okay, after that, just execute the tar command and just execute everything. Like don't leave anything. Tar hyphen xvz.
Starting with CP.
Come again.
Starting with CP only.
No, this CP command you already. Come again. You have already copied the tar file in your directory, right?
Okay. Okay.
Can you see it here?
Yes, I can see.
Okay, then execute this command. Tar.
So that command has to be started with CP space or not?
No. This
No.
is the command to untar. Just type this tar hyphen xvzf and then the tar file. That's it.
That is saying that not found in archive.
Just it's better you just share
in
your
command, I think.
share your screen. Can they share their screen, Kavita?
I think there's no option of
No,
sharing this.
I think we have to make them the panelist. So which is not feasible right now.
In this, just let me know that if this second command also ends with dot slash.
No, it doesn't.
Oh, that's what. So those are important things. Yes, it extracted now.
Okay.
Okay. Superna, in the meantime, let's just check how others are doing as well.
Yeah, sure.
Anyone else is there, all of you are able to execute, you're able to get the results, everything is okay? Just want to make sure all of you are able to.
So inside the workshop folder, you will have a vectorad folder. Inside that, you will have this first dive. So you need to double click that, and that's your exercise. So all you need to do is, as I mentioned before also, if you think that the portion of the code is complete here, just press a control and enter. You need to fill something in part 2 and part 1 and part 2. Just be aware of that. You should write your code there, and then you should do a control enter. And in the final step, this step will just execute your command, and you will get the results here. So anyone who has completed, please raise your hand. And anyone facing any issues, please let me know. I am mentioning to all of you the code is not complete. You should complete the code and then press a control enter. Some of you have mentioned it's showing some error. That's just because you have not completed it. That dot dot needs to be replaced with the code. In block 1 and block 2, you need to mention the code, whatever you think is appropriate for that portion. Block A and block, like the first part 1 and part 2 of the code is not complete. So you, what is missing is you need to create a queue. That queue is not created. And in the buffer portion, you need to pass two parameters. One parameter is passed, the second parameter you need to write yourself.
Superna, there is a request for also showing the code for selectors.
Yeah, I have displayed the entire code. At least they can pick it up from here, whatever they want.
Yeah. So just repeating, once you get the answer, please make sure you take a screenshot of that and save it, and you can send it to Kavita once you're done with all the exercises through the workshop.
Yeah, the complete code and the results you got. So how much more time we should give Kavita Helen?
Let's give another 5 minutes for people to complete, and then we can move on. Superna.
Okay.
question on the chat window. Run selected cells, and how does Jupyter Notebook say? So all that you do is get into the specific Jupyter Notebook. Inside that box, you do a control enter. You should be able to run the code. That is how we execute. Alternatively, yeah.
You need to do for all the boxes separately. It's not like if you execute the last box, all the boxes will be executed. In all the box, I think it's gray colored box. You just go to the box, click there, and press Control Enter together. You'll see it will display something like overwriting the file or writing the file, something like that. So that's like indication that that block is getting executed. And in the final block, you will see the results as soon as you execute. But make sure not to skip any step, because if you skip one step, the code won't be complete and you will not get the correct answers. So I think Ellen, someone has displayed, like I think Shukra Giri, he's telling he's getting some error, but I didn't see any error. So
No. I think we answered the error piece of it.
Okay.
Probably this can be ignored.
Okay.
Yeah, I think he says that he got the results, so we are good.
Okay. So I think we can move on, right, Ellen? It's already 5 minutes past. And let me know.
Yeah, I think let's get started then. Let's move on. So I think most of you, is there anybody who has not completed? If you can just raise the hand, we can just wait. Can you overall code screenshot? Can we take the overall code screenshot along with the result is enough? Yes, yes, Chandra, that's good.
So after you have like executed all the blocks, you will see a main.cpp in the left panel. Like if you open the Jupyter Notebook, on the left side, you can see a main.cpp file. So if you open that file, you will get the entire code together. You can then paste, copy the code from there or take a screenshot from there. Should we move?
Yeah, is there anyone who has not completed? Can we have show of hands? Yeah, Superna, yeah, maybe, yeah, it's good if you can show the walk through the thing, right, on your side before we move on, so that people are able to see it.
You mean the entire exercise? Oh,
Yeah,
Kavita,
yes.
can you paste the mail ID through the Jupyter Notebook you are telling, right, Ellen?
So whatever, now that we have given some time for people, now can you execute and show people?
Okay, but that was the like that's the competition. So if I am showing it to them, like I showed the code to them, the entire code, but they need to understand what they want to put there. I think you want me to execute that also.
Yeah, Kavita, what do you suggest?
Sorry, Ellen, can you repeat that, please?
No. What I was saying, there was a suggestion on the chat window to exactly share what the code is and execute and show on the screen. So I was just thinking. So what Superna was saying is that's the contest is all about that. So
Yes.
that's why I just wanted to check if we can share, and then what do you
No,
recommend?
she is right. Let her go with the flow, because whatever she shares, right, the participant needs to understand that and then work on their own. Yeah. And then send us a screenshot. So if she shows that initially, it doesn't make sense for the contest to run, right?
Okay, okay. So I think there's a question on which screens we need to share. We got the code executing without error. So
you need to share the entire code and the result that you got.
yeah. So
just-
Superna, can you repeat how you extract the CPP file? You can just show that on the screen if you want. How to extract.
Okay. For that, I need to execute all the steps itself.
No, just show where to extract. I think should be okay. Just
Okay. So can you see my screen?
yes, yes.
Yeah. So what you need to do is, after you have run this final step, that is executing your code, you will see here like along with this makefile queue and recent code.sh, there will be a couple of other files. You will find a main.cpp file that you are creating in this step. So that main.cpp, you can double click to open it. Like this, suppose if I want to open the makefile, I'm double clicking and it's displaying, right? So if you click on that main.cpp, it will display it for you in a tab. So all you need to do is, you just need to somehow either take screenshots or copy that content. Like if you just copy and do a Control C or anything, just right click and copy. Whatever you want to do, just do that, and you can paste it, or you can take a screenshot and share it with us. And when you are executing this step, you will see a result here. So a result will be displayed here. All you need to do is you need to give us the entire code that you got through main.cpp and the screenshot of the results that you have got here. So if you execute this, you will get this properly, following all the steps, you will get a result here. So all you need to do is, you need to share that results and the code together. I think I'm clear.
Yeah, Superna, so they have to copy the text in the overall code and then share
That
it.
anything they are comfortable with, and if they want to take screenshot, they can take a screenshot, or they can copy the content and paste it in a Word and send it to us. Anything, any way that they feel it's efficient for them, but it should be, the entire code should be there and the entire result should be there.
Okay, okay. Okay, I think let's move on. Maybe Kavita, we can also let's see if we can give some time after we finish. If they want to do some exercises, they can continue to do, and then they can submit the results as well. So let's go move on. Superna.
Yeah, if you guys are still stuck and want to take more time, maybe end of the day you can submit the codes to us. Thanks.
Can we add the poll? It's the time for a poll now. So. Yeah, let's wait for the poll. It's time for a poll. So what do you think will be a host, and what all will be the accelerated devices that will be connected to the host? It's a very easy one. So you basically need to choose the option where you run your code. Okay, yeah. Okay, the answer is CPU. CPU is the host, and you upload it to Gen 9 is a GPU, DG1 is a GPU, and FPGA is another accelerated device. So CPU is the host, and rest of the three are accelerated devices. Okay, so let's go in more details to that. So see, this is a CPU or a host. The host is the CPU basically. So this is a portion from where you launch the port and to be uploaded in the accelerated device. So you can have GPU, you can have FPGA or any other accelerated device. And you can also have CPU as an accelerated device. So you can offload the port from a CPU to a switch to another CPU to a CPU. So you can make the code offloaded to the CPU itself. And so why we call this as a heterogeneous programming language is it's a mixture of multiple platforms, as we can see. So we can have a CPU and we can upload our code to a GPU. So those together, the CPU, GPU together, this forms the heterogeneous platform. Okay, let's see how the execution flow occurs now. So whatever you have executed in the code, let's see what is happening internally for that. So in your code, as I showed you, you will have the host portion of the code and you will have the device portion of the code. Everything is clubbed together in DPCPP or SQL rather. So we have single source, but it has a host portion and a device portion, right? And the device will have its compute unit where actually the kernels will be executed. So let's see how it gets executed. So we have a host code and the device code. Host code anyway gets executed on the host itself. For the device code, as I already mentioned, the device code gets submitted to a command group. You can have multiple command group where you can submit multiple kernels through command groups. And so what command groups help is if you have given multiple kernels, so command groups create a graph out of that. So if any kernel is dependent on any other kernel, that acyclic graph that is created by the command group. So it helps in moving the data from device to host. It creates a graph to help itself understand the dependencies. And then after that, it helps to transfer the kernel to the device through a queue. So as you can see, we have a command queue here. So as I already mentioned, every device should have its individual command queue, but there can be multiple command queues for the same device. So I think I'm making sense here. So what I'm trying to make you understand is a particular device can have multiple command queues. Whereas the same command queue cannot be for multiple devices. Like a command queue will be specific to a particular device, but there can be multiple command queues for a particular device. So all this, there are multiple command queues here for this device, and all of them gets executed on the device. So this is how the flow goes on inside. So now we will see what happens inside the command group. So a kernel instance is created. So I will talk about ending and work group later. So a kernel instance will be created that we put in the command queue. So if we have multiple kernel instances, a command queue creates a work pool. So the work pool saves all the work, and then we decide which work, like according to the graph that I was mentioning, gets created. We select which work should be executed in the device. So next thing is the memory model. How is the memory? How the memory works inside? So as you know, inside the GPU, we will have execution unit, we will have L3 and all those things. So the execution unit is basically executes the small portion of the code. So if you just imagine that you need one to run 100 iterations in your 100 or 1,000 iterations in your GPU device or any other accelerated device. So you should consider, for parallel programming, you should consider each of those iterations as a single unit. So all those should be independent and should have the power to execute independently. They should not depend on each other. That should be an independent unit. So those units of code will be executed in our execution unit. So how is the memory structure located? We have a global memory. Global memory will be the memory that is common to the entire device. That means that all the compute units have access to the global memory. A part of the global memory is the constant memory. Constant memory, what it does is all the constant values that are there for the code get stored in the constant memory. After that, we have a local memory. Local memory is specific to the compute unit. I showed you how the compute unit is, how there are compute units, multiple compute unit or execution units for each device. So local memory is basically a particular, like every compute unit has a particular memory that is called a local memory. And then we have private memory. Inside compute unit, we can have multiple execution units clubbed together. And that individual execution unit has a memory that is known as a private memory. So basically, if you consider as a particular thread is getting executed, so if the thread have a particular memory, that we'll call as a private. So this diagram will explain it in more details. So the entire chunk of iteration, if we want to divide in multiple groups, let's divide that 1,000 iterations in 500, 500. So each 500 we will we want to execute in this work group, and 500 we want to execute in the other work group. So how the memory works is each work group will have its work item, or the particular thread where the actual iterations is each of the 500 iterations will be executed in individual work item. And then this work item will have its own private memory. The entire work group will have its local memory, and all the work group together will have a global memory, and a part of that will be a constant memory. I think now that you can understand how the memory structure is. So also we have the concept of unified shared memory, where instead of creating buffers, as you were mentioned, as we saw before, we were creating buffers for the data to be transferred in between host and device. So what unified shared memory does is, it just uses pointer for memory allocation, and the same memory gets copied to the device. We don't need to create buffers for that. So today I am not going in details for the unified shared memory. If anyone is interested in executing unified shared memory, there are 3 types of execution for unified shared memory. One is the explicit data movement. One is the shared data. So the shared data, what is done is we allocate a memory through pointer in the host, and the same memory is shared across in the device. But what is done for the device is the device for the first one, the explicit data movement, what is done is we allocate a particular memory through pointer in the host, and using memcopy we copy that portion of that chunk of the memory to the device, and we use that. So these are the different uses of USM. And the third is we can send the data over a PCIe or any other bus from host to a device. So there are 3 types of USM code. We have the explicit, and this is the implicit and this is the explicit. We have the explicit and the implicit code sample in the same Jupyter notebook where you had executed the vector as code. Feel free to go through that code, and if you have any questions, please feel free to contact me post the workshop. So the last module is the kernel module, the kernel execution module. So as I was telling you, so just consider the entire queue as the 1,000 iteration of a code that we want to execute. So this entire queue, we call it as ND range. So ND range is the entire range through which the kernel executes. So why we have created this extensive work group and work item concept is, sometimes what happens is there may be some dependencies, and all the chunk of code may not be executed independently. So what we sometimes want to do is we want to manually specify this chunk of code can be executed independently in a work group, and this chunk of code can be independently executed in a work group. In that, we can offload with more efficiency into a device. So that is the entire concept why we have kept for the users who want to deep dive into those. We have kept a concept of work group, subgroup, and work item explicitly for the developers. Otherwise, even if you are not mentioning anything, and if you are writing the code, you will you always be assured that the entire thing you are offloading to the code gets divided into work groups and little work items, and the execution goes on inside. So the subgroup concept that is mentioned here, that is an explicit concept of Intel. So Intel has given this concept. So if I mention to you in more detail, so in this cube we will have, as you can see here, this entire 4x4 block we have considered as work group in this cube, in this entire ND range. So this is a work group. So what is the issue with work group is that a work group will also, the small blocks inside the work group are the work items. So these individual work items will be executed in a work group. The problem with work group is if you have two work groups, it's not possible for the work items of different work groups to communicate. For that, we have kept a concept of subgroup. So what subgroup does is, subgroup is basically a portion of the work group. So here you can see two blocks we have kept as one subgroup. So what subgroup does is, even if you are dividing the work group in two chunks of subgroups or in multiple chunks of subgroups, what it does is the work items inside the subgroup can interact with each other, and still the two chunks can execute independently and interact. So that is why that is the entire concept of subgroup. So the work groups, as you see, the work groups are further divided into subgroups, which makes working with 3D spaces very easy. Work item is a subgroup. Work item in a subgroup can communicate directly using shuffle operations without explicit memory operations. So as I mentioned, the work items within the subgroups, within two subgroups or within different subgroups, can communicate with each other very easily, unlike a work group. That is an entire reason we have created the subgroup. And work items in a subgroup can synchronize also using barriers. So you can always use a barrier to create explicit synchronization between different subgroups, and you can do that for any chunk of data. So you can use the barriers for work group, for subgroups, for anything. So yeah, so this entire ND range memory will be the global work size, and then you will have a local size. So you will have two IDs through which you can address a particular work item. One is a global ID, that is its identity across the ND range, and one will be a local ID, that will be its identity for that particular work. Just to make things clear, I have an example here. So those of you who are used to image processing, suppose you want to process an image of 1920 by 1080. So every pixel in that image needs to be processed, right? So this entire chunk of 2 megapixels we can consider as a global size. So if we want a particular operation to be done across this particular image, so each and every pixel of the image needs to do that operation. That operation needs to be done each and every image. So the entire thing is a global size. So what we can do is, sometimes it's very difficult to run each and every megapixel parallelly, because there are some hardware limitations sometimes, or there can be several other things that will restrict us from doing the entire chunk together. So what we can do is we can split it into smaller groups of pixel blocks, and those are the local size. Local size is basically the size of the work group. So here, if you see, if you don't mention it explicitly, this is a syntax, right? Whatever the same syntax that we executed. Now you don't need to pass this. all you need to pass is the range. So, so the range, if we inside parallel for, we pass the range. That is when we are explicitly not defining the work group size. But when we are explicitly defining the work group size, what we need to do is, first we need to mention the global range. Within that, we need to mention the local range. So this is the work group size, this is the work group size, and this is the ingredient size. This is global size and this is local size. So you can see, one thing you should keep in mind is the work group size should always be divisible by the local size. Okay. Okay. Yeah. So yeah, as I was telling, we should suppose this 1920 by 1080 we have divided into 8 by 8 blocks. So it should divide this 1920 by 1080. So obviously, because you are dividing the entire chunk into small chunks, so if it's not divisible, then the work will not be done properly, and some chunks will be left out. So you will get the operation will not happen as you expect, and you will get a compiler error that is invalid work group size. And then one more thing to keep in mind is you should try to make the work group size as optimum as possible. So so here you can see that this 10 by 10 division, it divides this, but the resource utilization may not be that much. So the smaller, like you should always keep in mind that the size of work group should be optimum, the smallest possible with the constraints. So that the parallelism is more. And those of you who are interested in DPC++, feel free to go to this GitHub link. We will share the slides with you. This will have all different kinds of samples, because in this workshop, I didn't go through any samples that has USM or NG range or anything. But if you go to this GitHub link in the oneAPI samples, you will have all kinds of samples. Feel free to try them. And if you have any problems, you are always welcome to contact us. With that, we can have the final piece, Kavita. Kavita will display the piece. So I basically showed you the dimensions. So I showed you a cube. So you can easily answer this. Okay, the answer is 3-dimension actually. So 3-dimension is the built-in support. For n dimension, you need to explicitly divide your n dimension into 3 dimensions. That's already supported. So the answer is 3-dimension. So with that, let me just summarize whatever we went through. So as I told you initially, DPC++ is a program for heterogeneous programming, like to run a heterogeneous program. So it's a programming model for heterogeneous platforms, and it's open standard. You are all welcome to contribute to it. So the GitHub link where our like development goes on is mentioned here. You can provide feedback, or you can like you can provide something, some new features that you think will be helpful for you. And one more thing is the entire model is a single source model that will help the user write the DPCPP code very easily, unlike most many other programming language where you need to mention two files, like multiple files for hosted devices. And DPC++, finally, if you say DPC++ is an ideal programming language for people who want to write a code in heterogeneous platform and like and don't want to go into like more details of the code. It's like the verbosity is minimal here, but you can always write your code, like you can always go deep also, but it's for the ease of use. So much things are already encapsulated here in DPCPP. So with that, I'll end my session. Vinuta will give you an overview of how to use accelerated tools and see whether the DPCPP code you have written is performant and how to make it more performant. With that, I'll close. Thanks.
Do we have any break now, Kavita, or I'll continue?
Yeah, I think we can take a 5-minute break. Sure, Supriya. We can take a break and then we can probably start back at 11:55. We'll take a quick break and come back. 11:55 we will start the next session. Vinita, in the meantime, if you want to try sharing your screen and all that, that would be great.
Yeah.
Yeah, I think we can get started, Vinita.
Okay. Good afternoon, everyone. I'm Vinita. I'm Technical Consulting Engineer at Intel. And in this session, I will talk about how we can use Intel Advisor and VTune Profiler to profile DPC++ applications. Am I audible? Is my audio clear, Ellen?
Yes, yes, Vinita. We can
Yes.
hear you well.
Okay. So this is a brief agenda of what I'm going to cover in this session. So I will give you an overview of what Intel Advisor is, and I'll talk about what Offload Advisor is for, how do you run Offload Advisor, how do you interpret report that the Offload Advisor provides, and then we will do some hands-on with Offload Advisor. Then we'll also learn about GPU roofline analysis and overview of VTune Profiler for the GPU, and we'll also have hands-on for these two sections. Okay. Yeah. I'm not sure if you have heard of Intel Advisor before, and so I'll just give an overview of what Intel Advisor is to you guys. Intel Advisor is a profiling tool which is targeted for improving the vectorization and the threading aspects of your application running on CPU. Okay. So this has many components or features in it, like a vectorization advisor, which lets you identify the high impact and under optimized loops and how you can unblock the vectorization. It also has another feature like a threading advisor, which lets you analyze, design, and tune the threading design options. It also has the flow graph analyzer, which is mainly for analyzing the performance of an application which is using TBB flow graph interfaces. And the last one is the roofline analysis. This is again one more important feature or a component of Intel Advisor, which helps you identify where the actual performance of your loop or the function stands with respect to the hardware limitations. And it will also help you to categorize your loops or functions to be compute bound or memory bound, and if there are any bottlenecks or what is the performance gap or what is the performance headroom with respect to the hardware that you are running on. So these are the capabilities that our Intel Advisor is providing, and the Intel Advisor is part of the IPS XE offering, which is a Parallel Studio XE offering. And now, in addition to this, we have a new capability or a feature which is added to Intel Advisor, which is called Offload Advisor. So Offload Advisor is a tool which allows you to collect the performance prediction data in addition to the capabilities of Advisor. So which means now here I can say this as Intel Advisor Beta. So Intel Advisor Beta is nothing but you will have all the capabilities of our existing advisor along with a new feature which is an Offload Advisor. So when you use Offload Advisor, you will be able to identify what are the potential regions in your application which can be offloaded to the target device, which in this case would be GPU or FPGA or any other accelerator. So to summarize this, so Intel Advisor Beta is a extended Intel Advisor which comes with capabilities of advisor and a new feature called Offload Advisor, and this can be used to understand the performance modeling, and you can also do some analysis and characterization of your application which is running on CPU and GPU. This also is a code modernization and performance estimation tool which supports DPC++, oneAPI, and oneAPI applications running on CPU and GPU. Okay. Now that you know what advisor is capable of, what advisor offload advisor can be used, what you can do is that you can run the offload advisor and application of your interest to identify the potential offload regions which can be offloaded to a GPU using by rewriting using a DPC++. So now let's understand what are different ways in which you can run offload advisor. And before that, I'll just give you a high level overview of what happens when you run the offload advisor. So when you run offload advisor, there are actually two phases in which it runs. The first phase is a collect phase that we call, and the second phase is an analyze phase. So during the collect phase, what it does is it runs several different analyses that are part of Intel Advisor, like the survey analysis, the trip count and flop analysis, or a dependency analysis, memory access patterns. There are several different set of analysis that are supported as part of Intel Advisor. So when I say collect phase, we will be running several of these analysis and we will be collecting some useful metrics. And during the analyze phase, what we will be doing is that using these the collected metrics, we will do a performance modeling for the selected target platform. So which in this case would be our Intel GPU, like the currently supported target platforms are Gen 9 and Gen 11, which are integrated GPUs as of now. And once the analyze phase is at the end of analyze phase, we will get a HTML report, which is a final report after running the offload advisor. So here there are, I have listed 4 different ways in which you can get the offload advisor running. So one is by using the Python scripts, which are packaged into our offload advisor. So these are called run_oa.py and collect.py. So these both are the Python scripts, but just the difference is that when you run_oa, it runs both the collect and analyze phase together and provides you with a final output. And with the second option, you will have to run a collect and analyze phases separately, which means that you can run first collect.py and then you run analyze.py to get the final output. The other variant is by using our advisor XE command line option. And the last one is by using the GUI. So this is still an experimental feature, and it will be available from oneAPI beta 09 onwards. And to make use of this GUI, you will have to set some environment variables. So with that, you will be able to use this latest GUI. So again, we have these different options to run offload advisor, which because depending on the user understanding, he can go for any of these options. And also these different options to run comes with sort of flexibility and control, and also with some known limitations. So for example, the Python scripts that are provided here, run_oa or collect, these are easy to run. User doesn't require to have some deeper understanding about what are the options to use and all. So we can just make use of these scripts and get the output. But here you will have some less control with respect to the options. If you want to use some specific options, you will not have that deeper control when you use these Python scripts. But when you go to the command line option, you will have more control on what exactly the options that you want to use, or what exact analysis that you want to carry out, and so on. And also another limitation is that when you use this Python scripts, you'll not be able to profile your MPI application. But using this advisor, the command line option, we can profile MPI applications. Okay. Okay. There are these few steps that we will have to keep in mind before running Offload Advisor, just to make sure that we get a very useful report at the end. So the first thing is to source the environment, and again, when you're on dev cloud, by default it will be sourced, so you need not source again. But if it is not sourced, you can source it. So which sets actually the environment to run Offload Advisor and make use of DPC plus and other stuff. And the other thing would be to request for the debug information. So when you build your application, include -g, which enables a debug information. So with this, advisor will be able to collect more and more performance metrics that are going to be useful. And then you can request for moderate optimization, which means that when you build your again application, you can make use of the optimization flag to be at least O2. And the last one would be to disable the inter-procedure optimization. So you again, while building your application, you can include this -no -IPO flag, which actually disables the IPO optimizations. With this, once you if you disable this optimization, then it helps advisor to collect more performance data. So all that you have to take care is that you enable the debug information by using -g, include at least a moderate optimization by using -O2, and then make sure that there is no inter-procedure optimizations by using -no IPO. Okay, so as I said, once you run the Offload Advisor on application of your interest using any of the methods that I just talked about, the final output will look like this. So finally, you will get a nice HTML report, which is very light, and also you can just wherever you can run Offload Advisor, which generates this HTML file, you can just copy anywhere and for viewing the result. This is how the final output from Offload Advisor would look like. So we will try to go through all these components that are displayed over here and understand what it is and what Offload Advisor is suggesting us to do next, right? So here, when you run Offload Advisor, we are going to use application which is built with -g and -O2 with no IPO, and which is running on CPU. It can be single-threaded or multi-threaded. It supports both sorts of programming models. So once you open this Offload Advisor report, by default you will be on a summary page. So in this summary page, there are several sections like program metrics, offloads bounded by, and some configuration and all those things. So what you will be interested would be the top offloaded section and also the program metrics section. So let's just try understand what this program metrics section is trying to convey, right? So here it's mostly the timing data of your application. The first bar that you see here, which says original timing. So this is the timing of your application, which is running completely on CPU. Okay, and then we have accelerated timing. So here original timing, it says is 13.84 seconds, and the accelerated timing is 1.63 seconds. So this is a timing wherein you are running certain portion on CPU and certain portion you have uploaded onto the GPU. So by offloading certain portion onto the GPU, what would be your accelerated timing? So the Offload Advisor is predicting that once you offload certain portions that it has identified, your runtime would be 1.63 seconds. And next we see target platform, which is Gen 9 GT2 here. So as I said before, we can specify a target platform for which we want the performance modeling to be done. So for example, in this report, I have specified the target platform to be Gen 9. So which means all these data that we see here have been modeled for this particular configuration or this particular GPU, which is Gen 9 GT2. And then we also, there is something called as number of offloads, which means that it has identified one offload, potential offload region in this application. And next we have time on host and then time on accelerator. So time on host is nothing but from the accelerated timing, which you see like 1.63 seconds. So out of this, 0.09 seconds will be running on CPU, and the remaining 1.54 seconds it is going to run on an accelerator, which in this case is going to be Gen 9. So which means if you add 1.54 and 0.09, you will get 1.63. So this is just a breakup of the accelerated timing. And next we have a speed up for accelerated code and Amdahl's law speed up. So I would say that you always have to look into Amdahl's law speed up. I'll tell the difference here. Speed up of accelerated code here is nothing but when you okay, so how do you get 8.9x is that if you divide your original timing with the time on accelerator, you will get the speed up of the accelerated code. So because this time on accelerator means what is the time that it is running on GPU or the accelerator. So you will divide original timing to the time on accelerator, that will be your speed up for the accelerated code. And then Amdahl's law speed up would be your original timing to the accelerated timing. So which means that here when I say accelerated timing, I said it is the combination of CPU and GPU. So when I say Amdahl's law speed up, whatever the speed up that you get, it's always limited by part of the task that cannot benefit from improvement, which means that there is still certain portion of your application running on CPU. So when I say Amdahl's law speed up, it will be original timing to the accelerated timing, so which will be 8.5x. Okay, and here we also have data transfer tags, invocation tags. So these are the timings that are required. So when I say data transfer tags, this is the timing that is required to transfer the data between host and the accelerator. Okay, so like this, there are several metrics that gets displayed in the program metrics. So whatever I said, they are going to be somewhat useful, and we will have to look at these metrics. Next, we also have offload bounded by section. So when I say offload bounded by section, so this is a section which says that, okay, your application would be bounded by any of these limiting factors. It could be bounded by compute, or it could be bounded by your the available LLC bandwidth, or it is bounded by the data transfer. So that means like if there is a data transfer overhead is too much, then it will be bounded by data transfer. Or if there are dependencies, which means that you cannot execute efficiently on GPU, then it will be bounded by dependency and so on. And next is this is a configuration, Gen 9 GT2 configuration. So this is the configuration of Gen 9 that we have modeled for. And the important thing here is that you see the sliders here. Actually, you can move these sliders to the left or the right. And suppose if so the current one is a model for 24 execution units on Gen 9. If you want to model it for more number of execution, you can, let's say, you can move the slider to the right. If you want to change the capacity of L3, you can move the slider. And similarly, if you want to change the bandwidth of L3 or DRAM, you can move these sliders. And also now currently it says integrated GPU, but if you move to right, it will become the discrete GPU. So once you move these sliders, all this configuration gets changed, but it's not real time. Like the moment you change, it will this data is not going to alter. But what you'll have to do is, once you change these sliders, the new configuration file will be generated, which you see this arrow mark here. You can download that new configuration file from here. And when you run Offload Advisor next time, instead of providing configuration as Gen 9, you can provide this configuration file, so that the whatever the performance modeling that it will do, that will be for your configuration file. Ellen, are there any questions?
I don't see any questions. Maybe we'll just pause a few minutes and then few seconds and then check if there are any questions. Any questions? If any of you have a question that you want to ask, feel free to raise your hand and we can just we can answer it right away as well. Okay, I don't see any questions on the chat window or the questions Q&A window, so feel free to continue.
Yeah, sure. Okay. So next, apart from all these things, we also have in the summary view, we also see top offloaded and top non-offloaded section. So in this top offloaded section, what we see is the top 5 the potential regions that the offload advisor has identified, along with the speed up that you would get by offloading this particular region, and what it is going to be bounded by, if there is any data transfer that is happening, how much of data transfer is happening. Similarly, we also get to see the top non-offloaded regions. So the way it identifies top offloaded regions, it also identifies the candidates that shouldn't be offloaded to the GPU. So it lists all the top 5 of them, and along with the regions why they should not be offloaded to the GPU. Okay. So this is a summary page. Similarly, if you see here next to summary, we also have tabs or pages for offloaded regions, non-offloaded regions, called reconfiguration slots, and so on. So so let's navigate to offloaded regions tab to get details of about the offload regions that our offload advisor is suggesting. Okay, so when we move to offloaded regions tab, it will look like this, wherein you will see the loop that offload advisor has identified, along with if you remember, I said it offload advisor, when you run offload advisor, it runs several different types of analysis like survey, trip count, flop, the memory access, pattern analysis, or some dependency analysis, and so on. So you will get to see all that data over here. So for example, if you can see here, you have the trip count data. What is you also have how much of L3 traffic that that is going to happen for this particular loop, and so on. So, and another interesting the feature is that you see here. As I was mentioning, there are so many other useful data over here, like elapsed time, total time, what is the dependency type, is it an assumed dependency or it's an explicit dependency, what is the estimated speed up. With respect to overhead, we have several metrics like offload tags, data transfer tags, invocation tags. So any errors or warnings you will see in the logs. I hope all of you are able to view this report, and at least we can now understand what offload advisor is trying to convey here, what is offload region that it is trying to suggest to offload into GPU, and what would be the performance performance increase that you would get by doing so.
Question. So they are asking what are screenshots they need to be shared for the lab. You can just mention that one.
Okay, yeah. So for that, you can here I have commented this particular line, right? For all these for execution, you can uncomment these and try to execute. If you complete executing all these, at the end you will get the similar report like the one I shared. You will have to share this report with us. Okay. Now, similarly, the way I showed for how you can use advisor XE, the advisor command line utility. Similarly, there are the Python scripts that are available that I talked about. So this is how you can, I'll just show how you can use these scripts. So when you use run underscore OA, it is going to be just one command, one line of one line, wherein instead of here I have used collect by, instead you will just specify run underscore OA.py. So which will do the collect and analyze phase together, and you will get the report at the end. You don't have to execute separately two commands, one for collect and analyze. That will do everything in one go. And other way is to use collect and separately and analyze separately. Again, the options that you can provide to these two scripts differ, and you will have sort of less control when you go for run underscore OA. The options are limited. You will have less control on what you want, what you don't want. It will be a little bit more when you come to collect.py. You'll have few more options that you can control. So in this case, you will run collect.py, and again collect, you will specify either full or basic. When you say full, it is going to run survey, trip count, flop, I think dependency, and also the cache simulation, everything. It will run everything when you say full. And when you say basic, it is going to run like survey, trip count, and probably the flop analysis. Okay, once you finished the collect.py, there is again analyze.py that you can run. After that, you will see the similar HTML report. Okay, so here also I have commented submitting it to the queue to actually make it run. You can always uncomment and start running later. So once you finish this step, you will be able to see the similar HTML output that you got from earlier, but you might see some difference in some of the metrics values. That would be mainly because with advisor, when you use command line utility, you have provided few more options, and here you're not. So there might be some differences, but that's okay. So if you see here, the speed of the data aspirated is 23, and when I use this is 20.5x. This should be okay. Yeah. I hope all of you are able to view this HTML report. Any questions? Shall we move to the next one?
Vinita, a small request. Before you move to the next one, can you just summarize, on your portion a bit, because we lost the recording in between.
Okay.
You can just summarize a few lines on what you thought, and then we can proceed. Thanks.
Okay, yeah, sure. Yeah. So to summarize about Offload Advisor, Offload Advisor is a tool which is mainly used to identify the potential offload regions in your application, which would get benefited by running on GPU. And I talked about different ways in which you can run Offload Advisor, and how the Offload Advisor would look like. It is a very simple HTML report. And you will see in under summary section, you will see many useful sections like program metrics and other stuff. And it mainly suggests what is that region that it is asking you to, or it is suggesting you to offload it to the GPU, and what would be the performance speed up by uploading it, and what it is going to be bounded by, and so on. Okay. Now we will talk about GPU roofline analysis. Okay. Again, the roofline analysis is part of Intel Advisor, which we were using which was mainly for identifying, the actual performance of loops or functions that are running on CPU on a particular hardware. So the same analysis can be carried out for GPU as well. So in this case, what we need is that at least one DPC++ kernel, which is running on a GPU. So that is the requirement here to carry out the GPU roofline analysis. And to give you an overview of what roofline analysis is, that it is this is analysis wherein you will get to see the performance of your loops or the functions with respect to the hardware limitations. So just a quick chart that I'll show that this will make easier to understand what roofline is. So here, once you run roofline analysis, you're going to get a graph which would look something similar to this, wherein your x-axis will be AI, which is arithmetic intensity, which is nothing but flop per byte, which means how many operations you could do per byte of data in your cache or a memory. And then your y-axis is going to be the gigaflops, which is nothing but a performance. And here you see the dotted lines, which they are not highlighted, sorry. You see the horizontal lines, dotted lines here, they are the compute roofs. And then the diagonal lines, these are the memory roofs. So that means when you start running this roofline analysis, it will run certain benchmarks. So using, when it runs certain benchmarks, it will get to know what is the maximum compute capability of this, the hardware that you are running on or the machine that you are running on for a single precision on the double precision data. That will be your horizontal compute probes. And similarly, it runs certain benchmarks to understand, to get the capability with respect to the bandwidth of your machine that it supports. That will be your the diagonal lines. These are the memory roofs. So we will see for all different sorts of different memory levels like L1, L2, L3 DRAM in case of CPU, and L1, L2, L3 GTI, SLM, DRAM in case of GPU. So Superna had already walked you through this particular memory hierarchy. So here, what you see is in in a system, what we will have is we'll have CPU and GPU. So CPU is connected to LLC, the last level cache, and which in turn is connected to the system DRAM. And then the CPU will have its own L1, L2, and L3. Similarly, GPU will also have L1, L2, and L3, and there is some special cache called SLM, shared local memory, which resides inside L3. And again, this is for Gen 9. This may change for other generations when we look at. This is for Gen 9. And next, this L3 is connected to GTI, which is a graphic technology interface. And this in turn are connected to the LNC, Uncore LNC. So this is shared between CPU and GPU, this LNC. So if there is a miss, it would be like, okay, there is a miss in L1, it goes to L2, then it looks at LSSLM, then L3, then GTI, then LLC, and then DRAM. So this is what it is going to be. So the memory hierarchy is going to be like this. So again, the latency for L1 and L2 is going to be less, or even for L3 and SLM. But once you go beyond GTI, the latency is going to be more. Okay, now coming back to GPU roofline. So the memory hierarchy that you saw, where you had GTI, DRAM, L3, L1, all, you will be able to see once you run the GPU roofline analysis, you will see all those memory roofs over here. And now, what are these dots? These are so when you run CPU, the dots are going to be your loops or functions that are running on CPU. But when you run GPU roofline analysis, these dots are going to be the DPC++ kernels that you have uploaded to GPU. So these are the kernels that are running on GPU. Now, let's say let's look at this dot. So this again, sorry, one more thing I forgot to mention. So when you look at the roofline analysis, I also mentioned that you will be able to categorize your loops or functions to be memory bound or compute bound. So there is a you can actually enable it under the guidance. I'll talk about it when we do a hands-on. So once you do that, you will be able to see, okay, if this is going to be a memory bound kernel or it is a compute bound kernel. So you will get to know about that. And also, if you look at this dot, it is far below from the maximum compute capability of this machine. So still there is a lot of headroom through this particular. And if you look at, let's say, this kernel, it is over here, which is actually bounded by, I'm not sure which memory it is, probably the GTI. So it is bounded by the GTI bandwidth. If we let's say, if we take this particular dot. So using GPU roofline analysis, you will be able to identify these sorts of bottlenecks if where your kernel is performing, what is the actual performance of your kernel with respect to the hardware limitations, and you'll be able to categorize them as compute bound or memory bound, and accordingly you should be able to apply the optimization methodologies. Let's quickly go back to Jupyter Notebook again, and now on the same directory, you should be able to see activity 2 running GPU roofline analysis. Double click on that, you will be able to see this. So this is the command to run the GPU roofline analysis. I'll not go in detail about all these commands. So when you do control enter to this cell, what you'll be doing is you will be writing this into a file. And now in this next cell, you're going to submit it to a queue. I have commented it. You can always uncomment and give it a try. And once you do this, it is going to actually run the GPU roof analysis. And finally, you will be able to see a report which would look like this. And one important thing is that, as I said earlier, you need at least one GPU kernel running on DPC, one DPC++ kernel running on a GPU, which means that now that using offload advisor, you have identified certain portion of your code which should be offloaded to GPU. So now next step would be to make use of DPC++ and rewrite that portion into DPC++, create whatever queue accessor, whatever is required, program it in such a way that you will be offloading that particular portion onto the GPU. So once you do that, that portion will be running on GPU. Now you don't know what is the performance of that offloaded kernel on GPU. So for that, you will be running GPU roofline analysis. So here, when I say, here, if you, the binary that I have used for this analysis is actually the binary which has DPC++ in it, and it is offloading some portions onto the GPU. So once you run, here in this case also we will get HTML, as well as you can always copy your you can always open this also in UI, or if you don't have that facility, you can copy it onto your local system where advisor is installed, and you can view it on a UI GUI. And under the guidance, you see show roofline boundaries. If you click on that, it shows, okay, if you see any of the dots falling towards this, where you see memory bound, they are going to be bounded by memory. Mostly they characterized as memory bound. And towards this, if you see the dots, they are going to be mostly, here, they are going to be mostly compute bound. And if you see in between here, they are going to be mostly compute and both the compute and memory bound. Are you all able to, I hope you are all able to see this HTML report. To just view this, you on the last cell, do control enter. For the contest, we are not looking at GPU roofline. Offload advisor report is enough. Okay. All good. Any questions? Anyone not been able to get this report?
So Vinuta, what all screenshots they need to send? They need to send for the offload advisor and now.
Advisor only. No, not for GPU roofline. GPU roofline is not required.
Okay.
Only for the offload advisor.
And what about VTune? Do they need to send for that?
VTune. 1 second.
Actually, there was a question in the chat box. That's why I was asking.
Okay. Okay, so if we are done with this, we can move to VTune. Any questions? Any help needed here? I think Superna for VTune again. I'll just tell about it when I go to that hands-on. Yeah, just what report they have to submit. Okay, so if there are no questions, let's move to VTune profiler. Okay. Again, VTune profiler. It's one of the popular profiling tool out there, and which is mainly used to actually identify what are the most time-consuming functions in your application. If there is any hardware-related issue like cache miss or data sharing and so on, if there is in order to visualize the threading activity and the transition in your application, where and why the application is spending time on input-output operations and so on. To understand all these types of issues, we can always use VTune profiler. Again, VTune profiler has a very rich set of analysis types like CPU hotspot analysis, microarchitecture analysis, the concurrency analysis, CPU GPU interaction analysis, the memory bandwidth analysis. Like there's a lot of analysis types that have been currently supported, and in this session, I'm going to mostly talk about the GPU hotspot analysis. The GPU hotspot analysis is part of VTune profiler from long ago, but the new part is that it is now able to profile DPC++ applications which are running on GPU. So when you download when you use VTune profiler beta, you will be able to profile your DPC++ application running on GPU. Again, when when you are going to use VTune profiler, the GPU hotspot analysis, which is supported by VTune profiler, is that okay? You have offloaded certain portion to the GPU now. You can either run the GPU roofline analysis to understand where you actually stand with respect to the hardware limitations, and now to further tune or further understand what exactly is happening inside when you run this kernel on the GPU, you can run the GPU hotspot analysis supported by VTune profiler. So when you run this GPU hotspot analysis, what VTune is going to do is that it is going to monitor our GPU hardware events and displays few metrics. And these metrics are useful. These metrics are going to be useful to identify how efficiently our GPU hardware resources are being used, and whether they are performing better or does it require any improvements, and so on. We'll be able to identify all these things when we run actually the GPU hotspot analysis. Similar to this is similar to CPU hotspot analysis, which actually displays the top time consuming functions in your applications along with so many other hardware metrics. But this is going to be for a GPU. And again, here the criteria is that for this analysis, you will have you will need at least 1 or 2 kernels that are running on GPU. Again, to run this, I am going to use binary. It's the same ISO 3DFT binary, so which has been uploaded to GPU using DPC++. And once you have that, you have some kernels running on GPU, you will be able to launch GPU hotspot analysis from VTune. So again, under GPU hotspot analysis, there are different configurations that to select from, like if you want to do some characterization, there is a characterization configuration, or if you want some deep source level analysis, there is a configuration for that as well. We can choose any of them. Okay, so again, VTune, this is supported in command line as well as in the GUI as well. Here I will show you the command line utility, and I'll also show later the GUI part of it. In order to collect the GPU hotspot analysis, what you have to do is it's very simple. You use something called as it's a command line utility VTune, and then the option collect, followed by what type of analysis you are going to carry out, which is a GPU hotspot analysis here, followed by a result directory, and then the binary. So this is actually going to run GPU hotspot analysis. Okay. So this is hands-on for it. You can do it along with me. This is not very complex, very simple. So what I have is here is that there is a kernel which is already running on GPU. So this ISO 3DFD, this has been ported to GPU using DPC++. So here we are going to run it. So before that, we are going to run it, write it into a file. And now here in the next cell, you're actually going to run it. So when you run it, certain portion is running on CPU and certain portion has been uploaded to GPU. So when you execute this, it is going to certain uploaded portion is going to run on Gen 9, which is there on Dev Cloud. Okay, once once you have a binary which is actually running on a CPU GPU, okay, you're good to carry out the GPU hotspot analysis. So as I said earlier, you're going to specify -collect followed by VTune GPU hotspot analysis, and then you will provide the result directory followed by the binary. And if it is taking any parameters, you will specify them here itself. And once it runs, it actually collects a lot of metrics, and you can view the result in GUI. But for simplicity, what we're doing is we are just going to display the summary page of it. So once you do Control Enter to this cell, you are writing this file. And now in the next cell, if you do Control Enter, it is actually going to run the GPU hotspot analysis. Once it is done, you will be able to see a summary report over here. Okay. It may take some time for it to complete this analysis. If you don't see it to be completing, then restart your kernel. I'll go ahead. It might take some time for you. So once it finishes, we are going to generate the summary page, HTML page, which would look like this. So what you will see here is mainly the elapsed time, GPU time. So elapsed time here it shows as 3.806 seconds, out of which it has used 0.55 seconds from GPU. And you will see how much percentage of our execution array was stalled or it was idle, and what is the GPU L3 bandwidth that it was consuming. It is consuming at most 81% of it. You will also see the top 2-3 the top time consuming kernels or the computing tasks that are running on GPU. And then you will see the basic information about the platform on which you're actually running this. So you see here the CPU is some Coffee Lake machine, and then GPU is it is not displaying GPU name though. Okay, all of you are able to do this. Superna, Ellen, any questions?
No. No, Vinita.
Okay. So, okay, yeah. So for the contest, you will have to submit us this the summary report. Okay. Now I'll just show the GUI part of it, how you can run it. So once you open the VTune Profiler beta, and once you set up your project and everything, you go to configure analysis. And once you click on this, these are the different types of analysis that the VTune supports that I was talking about, like the CPU hotspot, microarchitecture, some anomaly detection. Few are like preview features, and few are not. So now it supports memory access analysis, threading, the GPU hotspot, interaction between CPU, FPGA, GPU offer, and so on. So we are interested in GPU media hotspot analysis. You can click on that, and as I was talking, characterization configuration is available, and source analysis configuration is available. You can choose any of them, and then click on this button so that it gets started. And then once it is run, the output would look something like this. So this is a summary page from UI. So whatever I showed earlier, it's similar to this, but we are just generating it in a HTML format, only the summary page. So here also you will see whatever I talked earlier: elapsed time, the GPU time, how much of time, how much percentage of time the execution arrays were stalled in GPU, the time taking, the computing tasks, what is the FP utilization. The FP utilization is nothing but if you're making use of SIMD units or not. If this percentage is low, that means you're not actually making use of SIMD units, which means that your code is not vectorized. You can look at vectorizing it so that more SIMD units gets used. And then next to the summary, you also have something like graphics tab. So here you will get some details about what exactly is happening inside GPU. So here you see these are the computing tasks that are actually running on GPU. So this is specifies what is the work size that it is using, global, local, whatever that you guys learned in DPC++. So and if you see here, it also displays the the bandwidth consumption. So L3 bandwidth consumption is more. So whatever the figures that you see here, the same is visible here also. So here it says this arrow is going from L3 to execution units, which means that how much of bandwidth that execution units are consuming from L3. Similarly, you have for GPI and LLC. All these metrics are visible here also. And then platform wave, you will be able to see the timeline wave for the execution units. Like if you can hover on these and you can see these metrics. Like okay, so here at this particular time period, the execution unit arrays were active for 71% and were stalling for 30%. And here there is no usage of GPU execution units. Probably here the CPU might be running and so on. Okay, so to summarize what GPU hotspot analysis is all about, it is mainly to identify if there are any bottlenecks in your DPC++ code which is running on GPU. Are there any memory access issues? How the kernel is actually performing, and so on. Yeah, so that is all is about VTune. I think there is one quiz or one question for VTune. Kavita, you can. Yeah. Okay. The question is VTune GPU hotspot analysis. It doesn't display EU array stalled info, FP utilization, GPU utilization, time taken by functions running on CPU. Okay, great. Most of you have answered time taken by functions running on CPU. Okay, the correct answer is the last one, the fourth. Time taken by functions running on CPU. So when you do GPU hotspot analysis, you will be able to display, you will be able to see the execution array, stalled information, FP utilization, GPU utilization, but it is not going to show the time consumed by the functions that are running on CPU, because you are running GPU hotspot analysis. It is not going to capture the things running on CPU. Okay. Thank you. If you have any question, please feel free to ask or post it in chat or Q&A.
So there is a question in the chat on how to access the workshop document. When I log into the Jupyter notebook, they couldn't see any lab sources. So I think that's it's taken care.
Mm-hmm. Okay.
So Superna, maybe it may be good to just attach the document to all the participants through the chat window, so that everyone has access to the document.
Oh, which document, Ellen?
No, the DevCloud, the setup document.
Okay, I think Kavita had posted a link which has that document. I think they can directly share from that. Kavita, can you share the link?
Yeah, I will send it in a while. Thanks.
Yeah.
Okay.
And
yeah.
Yeah, go ahead.
No, nothing, Iran. So I was about to say that's all from my side for advisor and YouTube.
Okay, sure. Okay, awesome. So I think we almost like 4 hours. That's like a lot of time. I just want to thank you all for being here for these 4 hours. I'm sure it is good use of your time. So just a quick reminder, I'm sure all of you are glued onto your screens and then trying to get your code up and running and then send the screenshots. So good luck to the contestants. So I know we've left some piece of it as an element for you to complete, and the whole idea is for you to get familiar with the code. That is the whole idea. So hopefully you're able to complete those and then send us the screenshots. In case you need a little bit more time, feel free to take a little bit more time. Your dev code access still remains, and even if you want to work after the workshop, you still have access for at least 120 days, so you can still access the dev code. Right. So with that, I think we will quickly summarize. Kavita, do you want to say anything before we summarize?
Yeah, I think it's great. I think thanks for the collaboration with KTech, NASCOM, right? Center for Excellence for Data Science and Artificial Intelligence. We saw some good active participation today in the workshop, and we have the recording for the event. And Supriya and KP and the team will help share that with the participants. I think overall it was a great workshop, and then thanks everyone for participating. I will let Supriya and KP summarize this event for the day. Thanks,
Sure.
Lakshmi.
Thank you. Yeah, thanks. Over to you, Supriya. KP.
Thanks, Kavita. What an enriching workshop that was. That definitely was an impactful one. And on behalf of KTech, COE, DS, and AI, I would like to thank all the participants for joining this AI Pathshala today in association with Intel. Special thanks and shout out to the entire Intel team for making this hands-on workshop a great success today. So a great thanks to all of you. Participants, stay tuned and follow our SM handles, social media handles, to keep yourself updated on all our upcoming programs. We will keep you posted, and we're going to put up the recording on our YouTube handle, which we'll share with all of you. Signing off from AI Pathshala this time is Supriya Samuel.